Good morning or afternoon. Don't know what time it is there, but it is 3:30 on Friday afternoon. I probably have jury duty on Monday, so I'm making this video. I'm extremely sorry that I haven't been there or here. A lot of last week, my daughter was really sick, and then I got really sick, and it was an extremely stressful week for me. I'm trying to be there as much as I can for you guys, but obviously I have a limit, so I'm really sorry. I should be here this afternoon as long as jury duty doesn't go too long. If it does, I'll text Miss Hatt or Miss Belk, and they can let you know. Maybe put a sign on the door. But we are going to finish 5.1. There's one property that is left that we're going to talk about. Before we do, we're going to refresh on fractions as they're on your review sections this week. So if you look in our example, we have 10 over 40, which is already reduced to 1/4, because they have a similar number that they're divisible by. Can anybody see what number that is? It's 10. So if you divide 10 by 10, that's how you get 1. If you divide 40 by 10, you get 4. You have to divide the top and the bottom by the same number. I'm sure this sounds extremely familiar to you, hopefully. So we're going to do the first problem, 8 over 64. What number are they both divisible by? 8. So you divide the top by 8. 8 divided by 8 is 1. Divide the bottom by 8. And 64 divided by 8 is 8. Number 2, 40 over 64, we can at least tell that that's divisible by 2. So we could try that. Divide the top and the bottom by 2. What's 40 divided by 2? 20. What's 64 divided by 2? 32. Is this as simplified as it can get? No. They're both even numbers, so they can be divided again. You could divide by 2 again, or if you notice, what number are they both divisible by? 4. If you divide the top by 4, sorry I ran out of room, 20 divided by 4 is 5. And then 32 divided by 4 is 8. So you will get the same answer as if you had divided in the first place by the number 8, or if you just keep dividing the number 2 or something like that. The next one, you see that they're both divisible by 10. 50 divided by 10 is 5. 60 divided by 10 is 6. I know I'm speeding along, but I'm pretty sure you're catching on to what's happening. Number 4, what is the largest number they're both divisible by? It's 9. 9. 18 divided by 9 is 2. 27 divided by 9 is 3. And then number 5. The only number that can go into both of these would be the number 3. What's 3 divided by 3? 1. And then 24 divided by 3 is 8. A lot of students forget about this 1. And 1/8 of a pizza is very different than 8 pizzas. I would know. Number 6, this time it's actually a mixed number. Some of you are really good with mixed numbers. If you remember, you multiply the denominator by the whole number. So 8 times 4, which is 32, plus 1, which is 33. And then the denominator of 8 goes on the bottom. And these are going to be equivalent fractions. We do it again with number 7. 6 times 2 is 12, plus 1 is 13. Keep the denominator of 6, and we got 13 over 6. The last, we have 6 times 10, which is 60, plus 4 is 64, divided by 6. Now, before we just circle this answer, we have to look and decide if this is in its reduced form, because we always reduce in math. If you notice, they're both even, so they're definitely not reduced. If they're both even, they're both divisible by 2. 64 divided by 2 is 32. 6 divided by 2 is 3. So this would be the final answer. At any point in the video, if students need longer to write something down, you can always pause, use the pause button, and I'd be fine with that. So on Thursday, we talked about the sum theorem of triangles and the fact that all of the angles in a triangle add up to 180. So if you look, this A is supposed to be down here. This is angle A, because we're going to try to solve for angle A in both of these. Well, we know that a triangle can hold up to 180 degrees. In this kind of problem, where we're just dealing with numbers, no letters, we can just see how many degrees we already have by adding them together. So 20 and 130 make 150. So if a triangle can only hold 180 degrees, we can subtract how much we already have inside to know that we only have 30 degrees left. So the measure of angle A is 30 degrees. On the second problem, it's a little different because we have x's involved. We can't do what we just did. However, what we can do is we can add all of them up, starting with the x plus 59. Continue to add with 84. And then x plus 51. We know all of them added up will equal 180. Alright, so then from here your algebra skills should take over. We have x and x, which make 2x. Oops. Then we will have 59, 84, and 51, which will make 194. And they'll still equal 180. Alright, so from here you want to get x by itself, so subtract that 194. So 2x will equal negative 14, divide by 2, and x equals negative 7. Is it what it asked for? Have we answered this question? Did we solve for the measure of angle A? We did not. We got to plug it back in. Here's angle A. It's x plus 51. We know that x is negative 7. So negative 7 plus 51, which will be 44 degrees. So this was a review of Thursday. The last half of the lesson goes over the exterior angle sum theorem. So if you look, you see we have angle 1 is out here. Angle 1 is equal to the addition of angle A and angle B. I will show you on the next slide what this means and why this is the way it is. But the exterior angle, okay, exterior means on the outside, the exterior angle will always equal the two non-adjacent angles added up. Okay, the non-adjacent is extremely important. Adjacent means they share a wall, so non-adjacent are the two angles that do not share a wall. They will add up and equal the outer angle. Most students, by the time they get to the test, they don't take the time to remember this theorem. So if I were you, I would star it, maybe highlight it, because it will come back and be very important to us. Okay? So this example we have asks to find the measure of JKM. So let's look for where JKM is. So JKM would be this outer angle. So we're trying to find the outer angle. So what do you think we need to find first before we find the outer angle? We need to find x. So again, the two non-adjacent angles will add up. So I'm going to take them, 70 plus x. They will add up and equal the outer angle, which is currently 2x minus 5. So if we know this to be true, we can solve for x and plug x back in to find out what JKM is. So we need to solve for x. We need to move the smallest x first. Which is the smallest x? Yep, 1x. So we need to move it to the other side, so we have to use our algebra skills. It's a positive x, so we need to subtract x on both sides. So I'm going to drop down my 70. 2x minus x will make 1x, I'll finish the problem by adding 5. So that means 75 equals x. Do I circle this and call it a day? No, I'm not finished. It asked for what the measure of JKM was. Okay, so let's go back to our picture. JKM is this angle out here. It is currently 2x minus 5. Whew, that looks jacked up. 2x minus 5. So we need to plug in everywhere we see an x. So instead of this x, we're going to plug in 75. Alright, 2 times 75 is 150. Minus 5 is 145. We can always check because these two inner angles should add up and equal that outer angle. So we can check. Let's see. So this one's already 70. This angle is x, which we found to be 75. Well, what is 75 plus 70? It is 145. Well, would you look at that? They match. Okay, so you can always plug it back in to check, and I highly suggest it. So I'm going to show you kind of visually how and why this theorem is true. We're going to kind of work it backwards. But first, I'll show you how to do it with our theorem. If you see, here are two non-adjacent. Again, non-adjacent means they don't share a wall with the outer angle. This angle I'm highlighting would be the adjacent angle. Okay, so our two non-adjacent angles will add up and equal the outer angle. Well, we don't know what this angle is at U, so we could call it x. We know that angle T is 50. They will add up and equal this outer angle, which is 120. Alright, so we continue to solve, subtract 50, and x equals 70. Now I will show you why in the world this theorem even exists. Now, I ask this a lot, and we still kind of struggle with this. What is the relationship between 120 and the angle inside of the triangle? What do they form together? And I'll give you a hint with this bright yellow line. They form a straight line, which means a straight line is 180 degrees. Do we all agree? 180 degrees. So if that is the case, and we already have 120 degrees of the 180, how much is left for what's inside of the triangle? You're right, that would be 60, because 120 and 60 make 180. Now let's look at our triangle. Highlight it in this salmonish color. What do the angles inside of a triangle add up to? They should add up to 180. So we don't know what this angle is, but we do know we already have 60 and 50 degrees. So how many degrees do we already have of our 180? We already have 110. What's 180 minus 110? It's 70. So this is why this property exists, that these two non-adjacent interior angles of a triangle will add up and equal that outer angle. Okay, you don't have to do it in the roundabout way that I did it, but I was just showing you why we do what we do. Alright, we do our next one. Let's look, we're trying to find this exterior angle. Okay, so the adjacent angle is always attached to it. So let's look at the two interior non-adjacent angles, which would be 25 and 80. So we would add 25 and 80, and they will equal that outer angle. So 25 and 80, excuse me, make 105. That's our answer. All right, we take it one step further. Just to do it one more time, we're finding the measure of AUT, which would be this outer angle. The property is that the two non-adjacent interior angles, so that'd be S and T, add up and equal the outer angle. So that's exactly what we're going to do. We're going to add 5x plus 10 and 58, and they will equal the outer angle, which is 11x plus 2. So from here, we need to combine like terms. So I'm going to drop down my 5x. My like terms are 10 and 58. They're on the same side of the equal sign, so I add them together like it says. That equals 11x plus 2. Alright, now I need to move the smallest x. My smaller x is 5x. I'm going to subtract it. So I'll have 68 equals 6x plus 2. To finish, well, almost finish my problem, I need to get 6x by itself. So I need to move this positive 2 to the other side by subtracting. So I'll get 66 equals 6x. Now we're down to the very last step. Because the 6 is multiplying by x, we're going to do the opposite and divide. So x equals 11. But I don't stop here. I don't circle this answer because I want to find the measure of angle AUT. Currently, the measure of that angle is 11x plus 2. But I need to plug in what I found for x. And what I found was 11. 11 times 11 is 121, plus 2 will be 123 degrees. This last problem is actually not on your notes, but it will be on the homework. So if you want to take a minute, go ahead and pause me and write this problem down, because I'm telling you right now that there are 2 problems on the homework just like this. So in the exercise 23 through 26, find the measure of each acute angle in a right triangle. So we're all very visual people, whether we like to admit it or not. So I'm going to go ahead and draw a right triangle. Alright, so it says the measure of one angle is 5 times the measure of the other angle. So the first angle we're talking about, the one angle that's boxed in, is 5 times. Well, what does times sound like? Multiplying. So 5 multiplying, if you want to put a dot or maybe a little x that you're multiplying, times the measure of the other angle. Well, when we don't know what the other angle is, when we don't know something in math, what do we always call that unknown? We always call it x. So instead of writing 5 times x, okay, we'd write 5x. So the first angle that they described, the measure of one angle is 5 times the measure of the other, is 5x. So then here's the question. There are 3 angles in a triangle. We're told that it's a right triangle, so one of them is 90. One of them is 5 times the measure of the other. So then what do we call this other angle? Well, what did we call it here when we referenced the other angle? We called it x. So the angle that we don't have yet is actually going to be called x. The most common mistake is that people don't remember to call one of the angles x. From here, you know that all 3 angles add up and equal 180 degrees. So you can take each of them, including the 90. So take the 90-degree angle, add it to your 5x, add it to what we call the other angle, and they equal 180 degrees. Alright, so we combine like terms, we keep our 90. 5x and x make 6x, and that equals 180. Subtract our 90. 6x equals 90. Divide by 6. X equals 15. Did it ask what x was? It did not. It says find the measure of each acute angle. I'm just reading the directions here. So since we called the other angle, that one missing angle, we called it x, we did technically find one of the angles, and it is 15. The other angle will be 5 times 15. And 5 times 15 is 75 degrees. All three of these angles should add up to equal 180, and they do. So when you get to this problem, please don't forget, when it says the other angle, okay, you'll always name one of your angles x. Alright, your classwork will be in your textbook. If you're 4th or 5th hour, you will also do this set of problems. Please draw the figure. It will help you out so that you can find all the missing angles. I hope to see you this afternoon for a good help class. I miss you guys, and I hope you have a good day. Deuces.